In this video, we're going to take a look at how we can implement a save load system using data-oriented design. Implementing save and load using DoD is fairly trivial, and to show how we do it, we're going to take a look at this game that I made. It's basically sort of like the game Balatro, if you're familiar with it, and it's a roguelike where we have this spinning wheel. We can choose different wheels and stuff, and we pick our wheel. Then we have different round selection. The menus are very similar to the Balatro flow, and if we play, we need to drop these balls into these 4 different colors, and the more balls are in the same color, the more points we get. So you can see we've got 5, 10, plus 5 points for every ball that is in the same color. And our goal is 300. Let's drop some more balls in here. Hopefully we can finish the level. Almost. Let's do one more. We can drop it in a different color now. It doesn't matter what color we drop it in. It's a pretty good drop with 5 of them in the same place. So 5, 10, 15. Each one goes up by 5. And now we got our reward. We got some money, money for unused spins. We have a shop where we can buy things. We can buy 1 more spin. We can buy, this one is plus 100 chips if 3 balls land on the same color. This one gives us 6 malt if 3 balls are on different colors. We can also have like modifiers, so each slot is worth more. We can have different balls we can upgrade. For example, let's try this one, and let's change. We'll change this ball to give us plus 100 chips. To give us plus 100 chips on red. So that one got modified. And now if we play and we drop this ball on red, it fell on red, and we should get 100 chips for this one. Let's see what happens. And we got plus 10 and plus 100. So we can modify different things. And the idea here is, let's take a look. This game was built using a combination of data-oriented design and being in Unity. For example, all the physics actually uses Unity physics. So what we're going to do is we're going to try and save our game and show how easy it is to actually save a game. Let's buy this Joker card that gives us plus 100 on 5. Let's try it one more time. Oh, great. Our boss is that our balls are debuffed the first time, so this ball won't give us any points. But let's try and drop all 5 balls on the same color, and we managed to do it. So that should give us plus 100 chips. So we got plus 100 from dropping that. And the debuff was only for the first round, so now we can try and drop on red. Let's see. Oh, again, we managed to drop 5 balls on red, and we have our ball here. It'll give us another 100 also, so we got a bunch of points. So we want to be able to save our game and load it. And we can see right now we are on the round complete screen. We've got $5, $2. We have our Joker, we have our ball, and if we exit the game and rejoin, because it saves every time we switch a menu, click continue, and we're back in the same screen with our same settings. So our game got saved. Also here we can do like the scoring speed. Let's make it 4.0. Let's turn off vibration, but turn on sound effects and music. So on, off, 4.0 off. And then we'll leave the game, rejoin, just to show how our settings are saved also. And if we continue and we go, we're on, off, 4.0 off, just like we were before. So our game got saved and loaded correctly. So let's take a look and see in the code how we're using data-oriented design to save and load our game in our settings. So here we are in the code, and with data-oriented design, we want to store all of our data in a single place. This is not ECS. This is pure data-oriented design. We want our data to be available so we can use it from wherever we want to. So we have, every time we do a run, in the game, we have what we call the run data, and it has all the information we need, all the data we need to run, to do a run and continue it and know what's happening in this run. So for example, we have which wheel did we pick at the beginning? How much rain do we have? What was the seed that we started this game with? There's also different seeds for the game, the shop. These are the active seed right now. So every time we buy something in the shop, the seed changes. So we'll get new jokers. So this is what that seed is right now. So when we continue our game, it knows what, it will always randomly generate the new shop items correctly. Stuff like what menu are we on. This is actually in the game when we're scoring. How many chips did we get right now? As the chips are getting counted, how many spins were we in? Do we have extra spins? Did we buy extra spins? Maybe the spins are changed because it's a boss and there's different spins on it. All these different things that are used by jokers, by basically all that we need to run this game with 70 plus jokers that do a whole lot of crazy stuff. How many jokers we have right now? What are the types? How many jokers can we hold in our hand right now? What are the sell values? Maybe the sell values change. Maybe there's a joker that changes how much each joker is worth. How many chips? Maybe some jokers, as you use them, the amount of chips they give you can decrease or it can increase, etc. So all these things, the shop data, they're all here in one place. This will probably look very weird for somebody who is doing object-oriented programming, but for DoD, this is really great. We can literally, any data we need is right here. We want to search for something, we want to know where something is used, like where is voucher purchase being used. And we can immediately take a look and see places like when you buy a voucher, we can take a look if it's bought or not bought. We can, in the logic, actually set it to false here, which is in the beginning of start new game. So when you start new game, we set voucher purchase to false. Every time you claim a round board, and if it's you beat the boss, so it'll be the third round, we reset the voucher. So it's really makes it easy to figure out what is going on by having all the data in one place. It actually makes things easier and actually reduces code complexity. So now that we have all this data, this is the best part. We want to be able to save our game and load our game. And all we need, because this is all the data we need to run our game, all we have to do is we just need to write out all these variables. And when I load the game, we just load them. And our game, our game is going to be exactly the same way which we saved it. So to do that, we're going to have a separate class called runData.io. And in this class, we are just going to write out all our data in binary to a file. And if you're not familiar with how this works, basically we can use our application.persistent data path to get a location which is stored either on your device or on your computer, somewhere where Unity can read and write from. And we just added the game name, and our file is called save.dat. And then we open a stream with this file name, and we open a binary writer, and we just write every single variable that we have. Every variable is written, arrays are written, etc. And we want to load the game. I'll add one thing, that it's very helpful for backwards compatibility to write out a version, what version of the save file you have right now. So for example, when we want to load version 1, maybe some things got added or we have to change some things. So it's really important to know what version you have. And every time you change your run data, we need to go in here and write out our new run data. We also have to change the version because people will have a save file that might not have this run data. And what I really like to do is always at the end write some magic number, like 1, 2, 3, 4, 5, 6, and then read it in just to make sure that everything worked correctly and nothing got missed. We also have here a load menu state only, so we can load only the menu state if we want to know what menu we are on. I guess I use it for something. We can always look and see what it was. And to load our run data, we just open a file stream to that same file, open a binary reader, and then we can read all that stuff. And you can see that we check our version, and then we're reading all this data. And the important part here is that we have to know what data we wrote. So up here, like for example, when we wrote the menu state, we wrote it as a byte, and our money is an integer. Our start seed is a unsigned integer. So here when we read these things, we have to read a byte here. Here we have to read an int32. Here we have to read an unsigned int32, etc. So it's really important to know. This way we know exactly what data we wrote, and we know exactly what data we're reading, because it's in one big chunk. And that's all we have to do to load and save our game. Right at the end, we are reading our magic number again, just so we can see to make sure it's the right number. It may seem like a lot of code, but the code does only one thing: it reads and writes. If we miss something here, it's really easy to find, because if you just use a debugger and step through it, you can immediately see that something has the wrong value. Especially if you go from an integer to a floating point, they're stored in a totally different way, and it'll be really easy to tell that spins used is now suddenly like 4 billion or something, and it's like, oh, I guess this is where things have messed up, and then you can go, okay, put a breakpoint here in total spins, make sure we're writing the right values, make sure the values are correct here, go back here, read them, and you can see, oh, this one line is wrong. It's because we missed something. It actually makes it really easy to catch stuff, really easy to figure out what is going on, and it looks very different from object-oriented programming, but it really helps reduce code complexity, and makes it really easy to save and load games. The same way we have slightly separate data. We have also our settings data, where we store if the sound effects, music is on, vibration, what speed we're doing it, are we skipping around one or not, and so we have our separate settings data IO, which loads this data. This is because this data is separate from the run data, so we immediately load this, and we save it every time that you exit the settings menu. That's it. Hopefully now you know how easy and simple it is to load and save data using data-oriented design. If you want to know more about data-oriented design, I'm writing a book, Data-Oriented Design for Games, being published by Manning. There's a link in the description, and it's not complete yet, but it's out in early access. Right now there's 5 chapters out that even you can click here and actually read the first chapter for free. It talks all about data-oriented design, what it is, about memory, why we lay out data in memory in certain ways, and also how to use data-oriented design to reduce code complexity. The next chapter, chapter 6, is coming out very soon. Hopefully, if by the time you're watching this video, it's already out. And that one will also cover save and loading in more in depth.